Now, let's open that up again one more time. Okay, remember this one is it's like the black box. This is my black box, except I'm exposing inside the black box with some of the state variables, some of the operations that are assigned to that black box, and inputs and outputs, flow properties. And all these other things are external systems, external either man-made environment or natural environment that I have to interface with. Now, this box here, I want to decompose and describe as a block definition diagram for it. So that's what this next DVD is for, is to show the structure of my automobile itself. So if I click on it, it opens up the next DVD. You'll see I've expanded the compartments, so let's just collapse the compartments. So how do we do that? We click on the object, come over to the control sidebar, come down to the compartments, and turn them off. Uncheck them. Okay, now our automobile system is going to be made up of, and let's just see what we're made up of. The black diamond, the filled-in diamond, means this is the composition, or it's built from. So the automobile system is built from my exhaust and fuel system. The exhaust and fuel system block is built from my fuel tank. And then, of course, my fuel tank has fuel flowing into it. See, there's that flow property. So fuel is flowing into my fuel tank. There's a chassis, a powertrain, which is built from the engine. And here we've used a generalization symbol, the open triangle, to show two specialized engines. So here I've got a 4-cylinder engine or a 6-cylinder engine. So this is a abstraction. The engine is an abstract object, and then I can have a more generalized one with more details defined. Okay, over here you notice I've got a wheel. It's a block, and here we've used the multiplicity of 2. So I've got 2 rear wheels, and I've got 2 front wheels. Okay? Then, of course, way over here on the right, I've got electrical assembly. I'm displaying one of the parts compartments. So if I click on it, remember, click on the control symbol, come down to the compartment, you'll see parts is checked. So this one, I just want to show that I've got electrical assembly is made up of 2 parts, a battery and a computer. Now, you'll notice that I'm showing it redundantly, the information. So the electrical assembly block has these 2 parts, but it's also being shown here. In SysML, it's recommended that you only show it one way and not show it both ways like I've done here. The tool will allow you to do it either way or both if you need to, but the specification recommends just showing it one way. Now you notice here that the black symbol is like a composition. So this thing is made up of this and this, but this white one is called a share relationship. So this audio system, my radio, my stereo, is shared by the electrical assembly. I can unplug it, take this box out, and put it somewhere else in a different automobile, where it's harder to unplug the computer or the battery. And so that's a different in the notation here. And then, of course, the computer has shared software, a software controller. So the idea here is I want to look at my system architecture level by level. So here is the entire system. the entire system is made up of these first level component parts. And I would describe the behavior for each one of these, or those activity diagrams, to identify the actions and then allocate the actions to the particular block that's going to perform the actions. So it's a combination of the block definition structure diagram and the behavior diagram to describe the architecture of my system. Now, if I come back over to the structure package for a moment, you'll notice there's a IDD, an internal block definition diagram. If I open that one up, that one is looking inside of a block and looking at more of the connections, the internal parts and the connections. So I'm starting to show interfacing information, if you will. So in this one, here's my powertrain, and I've got a composite symbol here. If I click on it, come back over to my sidebar, you'll see I've got structure here checked. Once, if you're doing a little mini diagram in this structure compartment, everything else is dimmed out. Okay? So the powertrain is made up of my engine, my transmission, my differential, my rear wheel, and my right rear wheel and the left rear wheel. And you'll see then these little black arrowheads are called, let's see, what are those called? Let me click on it over here. They're called item flows. And what type of item can flow? Well, there are three types. Let me do the right-hand pop-up menu on the symbol and do the rename like we normally do in Cradle. And here I can give the item flow a name, but then down here, I tell it what stereotype is flowing for that item flow. If I look at the drop-down list, it can be a block or an actor, a signal, or a value type. So in SysML, in Cradle's implementation of SysML, there are three types of stereotypes that are the primary interfacing information. A block like fuel, that would be a block, or a report would be a block. A signal like a fire alarm, or a signal that gets sent, an asynchronous signal. And a value type is like a variable, something with a value. Okay? So each one of these, air is a block. I think we noticed that, right? If I do the right pop-up menu and rename again, yes, it's a block. Where power, if I click on it and do the right pop-up menu rename, it's a value type because it's got a value. And then I've got torque. That's going to be a value type as well. And if I want to change it, then I change it to a different stereotype and then give it a different stereotype name or pick the stereotype from the list. So I could pick a different stereotype here, a signal instead of a value type, or a block instead of a value type. Remember those three kinds of stereotypes that are used to pass information, matter, or energy or things to the system. Everybody okay so far? So this is an internal block definition diagram, and here we're trying to show the interacting parts, the interactions, and the information being exchanged between the internal parts. So this is a great interface diagram.